Alright, we got that? Okay, so a factorial is so I'm sorry this landed in there and I just showed you one and I assumed you knew it. So a factorial is basically it's n factorial means I keep multiplying until I get to whatever that number is. So if I had 5 factorial, that means I multiply 5 times 4 times 3 times 2 times 1 until I get down to 1. Okay, I work it backwards. Okay. The special case of this, though, is if we have 0 factorial, you just have to know that that's equal to 1. Okay? Alright, doesn't come up very often. So I can, what we call this an expansion. Alright, so when I expand 4 factorial, what do we get? 4 times what? 3 times 2 times 1. Okay, so when I multiply those numbers together, what do we end up with? 24. Good. Alright, we just did the 5 expansion. 5, 4, 3, 2, 1. When we multiply those numbers, what do we get? 120. Okay. Alright. This one wants us to write the first 5 terms, so this is kind of what you kind of did in your homework last night. So a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5 is what we need. Alright, so I'm going to put in a 1 to begin with, so 2 to the first over 1 factorial would just be 2, wouldn't it?
Yes.
Alright, 2 squared over 2 factorial. What's 2 squared?
4.
And 2 factorial is just 2 times 1, so it is
2.
2, so my next number is still 2. Oh, wait a minute. How did I forget? A starts with 0, so my first term is actually my 0 term, isn't it?
Yeah.
Yeah, sorry. Squish that in there. Sorry about that. 2 to the 0 over 0 factorial.
0.
What's anything to the 0 power? 1. And what did we just say 0 factorial was? 1. So that answers 1. And guess what? We don't have to do a sub 5. Isn't that nice? Okay. 2 cubed over 3 factorial. What's 2 cubed? 8. And then 3 times 2 times 1. Actually, do I really need to multiply it out?
No.
Can't I cancel 2 into 8?
Yeah.
How many times?
4.
4. So 4 thirds. 2 to the 4th over 4 factorial. So what's 2 to the 4th? 16. And then 4 times 3 times 2 times 1. Now check this out, because we do this a lot. Okay? What's 4 times 2? Into 16, how many times? 2. So I used both of those to cancel with the top. So I end up with 2 over 3. Okay. Alright. So we only doing one of those. Let's move. We're moving on. We're moving quick today. We got a lot of different things to talk about. So here's how I deal with this. I want to be able to cancel, and we know we can cancel. I want to get to the biggest factorial in the denominator, and if the bigger number was on the bottom, I get to the biggest one to expand it to the biggest one on the top. So my biggest number in the bottom is 6 factorial. So I'm only going to expand that to 6. So I do 8 times 7 times 6 factorial. I'm going to keep the 6 factorial because I know that's going to cancel, right? Mm-hmm. Whatever the other number is, I'm going to expand that. 2 factorial is pretty easy to expand, right? Mm-hmm. All right. If it was bigger than that, I'd probably be a little bit more concerned. All right. What happened? What do I get to cancel right away?
6.
The 6 factorial's gone. 2 goes into 8 how many times? 4. What's 4 times 7? 28. Alright, we good with 16? Yeah. Alright, so let's look. Okay, this one's going to be a little bit different. So I see this big number 6. I know I should expand it as far as what? 5. Okay, so I'm going to go 6, 5 factorial, keep the 5 factorial. Can't I get a 2 factorial out of the 3?
Yeah.
So I'm going to keep 2 factorial, and I'm going to go expand the 3 factorial as far as the 2 factorial. Okay. Thank you. All right, what's going to cancel now? 2 factorial cancels, 5 factorial cancels. Ooh, 3 into 6 how many times? 2. So my answer is 2. All right. You ready for this? This one came up in BC Calculus yesterday. Okay? So this is important to some of your futures here. Okay? Those of you that go on for a couple more years here. It does pop up. So I'm going to expand, and remember this, when I do this expansion, what am I subtracting each time? 1. Okay, so if I have the n term, what's before the n term?
N minus 1.
N minus 1, isn't that what the denominator is? So, don't these guys cancel? Yeah, what's my answer? N. It's concept very easy, but it looks really complicated, right? It's one of those things, you know, you can dazzle your friends with, right? Because it makes you look really smart. All right, next thing, summation notation. Do you have to fill in there?
Yeah.
Yeah. Dazzle them with math. It'll impress them all. Almost there? No? Okay. Huh? So C is a constant. Yeah, it's the way it got typed into an equation. It looks weird. It's the word constant on that. It's because when you put it in an equation editor, anytime it says TAN, it looks like it wants to recognize it as tangent. So. So at the level of math that you're in at this point, it's rare that we're at the beginning of something, right? We're kind of the culminating, we kind of are finishing up our study of algebra, right? Or finishing up the high school study of algebra. So it's rare that we start something. This is new today, right? That funny looking letter, right? It looks kind of like an E. It's a sigma, all right? It's a Greek letter sigma. And we start it here because you see it up here, right? We use it when we get to that second year calculus. Okay, so we're going to learn about it the next few days, but again, it's notation, okay? Whenever you see that, it means sum, okay? It means you're adding things together. So that's why we call it summation notation. And basically, yesterday we talked about an arithmetic sequence. So when we add those terms of that sequence together, that's the summation. All right. It looks like, what else? Oh, there's some things missing on there, I think. I don't know what happened. It doesn't look like they got typed in. So I is what they call the index of notation or of summation, and typically it's down here. We don't, in this class, in this book, they use an I. In calc, we usually use an N there, okay? N is the upper limit, so N usually goes on the top. It's usually a number. And then 1 is typically we start with 1. We don't go negative on this. We either start with a 1 or a 0, okay? Typically it's a 1, unless they tell us otherwise. These are the properties. So basically, if we just have a number there, it's typically when we add up the numbers, it's the number times whatever this value is on top. If we've got a constant in there times a function, the a is representing a function, we can take that constant and put it out front, add up the numbers and multiply by the constant. We can, if we have two numbers where two functions we're adding together, we can take their sums separately. Same thing with subtraction, we can subtract them separately. Okay? All right. Definition of a series. Do you have to fill that in? No, we gave it to you. Wasn't that nice of us? Okay. So this is the official book definition of a series. It says consider the infinite sequence, which we talked about yesterday. That's the algebraic notation for a sequence. It's the sum of the first n terms of the sequence is called the finite series. Okay. Or we call it the partial sum of the sequence. So we can add up the first 10 terms or the first 100 terms. Okay, that's typically, and we're going to have a formula to be able to do that today. The sum of all the terms of an infinite sequence the big difference is this top number here is infinity. With arithmetic, we can't find it. Okay, when we go to geometric, we'll be able to find something. Okay, so that's starting tomorrow. All right, so this first one, we're going to go ahead, we're going to find the sum. So here's what I'm going to do with it. I'm going to basically, that's not too big, so I'm going to plug in my numbers and add it up. All right, so first thing, this is the function in here, okay? And it says to sum it because I've got the sigma notation. I'm going to start by plugging in what number? What does it say? 1, and I'm going to stop when I get to plugging in 5. Okay, so I'm going to plug in those numbers, and I'm going to write out a list of numbers. So I'm going to do 3 times 1. Plus 3 times 2, right? Because my function is 3 times the number. 3 times 3, 3 times 4, and 3 times 5. And yeah, there was probably a shortcut with their little, all that notation, but this works good too. All right, what's 3 times 1?
3.
Plus 6 plus 9 plus. All right, you may use your calculators and add that up and tell me what you get. 45. Could we have done what they told us to do, factored out a 3 and added 1 plus 2 plus 3 plus 4 plus 5? Would that have been okay too? You're going to get the same answer. Okay? So, kind of up to you. All right. Oh, here's the one that was similar to homework last night, right? Only we didn't have to find the sum. So what number am I starting to plug in? 0. And where do I stop the madness? 4. Okay, and I'm just going to go ahead and plug it in the way it looks. Okay, so 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial. Okay, what's 0 factorial? 1. So really this first term is just 1, isn't it? What about the second term? Also 1. All right. 2 factorial ends up being 2 times 1, which is 1 over 2. 3 factorial is 3 times 2 times 1.
1 over 6.
6. And then 4 times 3 times 2 times 1.
1 over 2.
Now, you have a calculator. Is it okay to put those fractions in your calculator and add it up?
Yes.
Absolutely. So use the functionality of your calculator, but I want a fractional answer. I don't want a decimal point. Okay, so see if you can get it as a fractional answer. typically when you start typing it, use the Control Divide button. Control Divide. Okay, and get it in, type them in as fractions that way, and typically it'll give you your answer in fraction. Do we agree with Ivan? Yeah? Awesome. All right. So, the next one. Okay. Go ahead and write that formula down. You got to write it down, right? Mm-hmm. So I'm going to show you, we're going to use this formula. This is the, I told you, very formula driven, this chapter, right? So this is the formula for this adding up the sum of a sequence that's arithmetic. All right. Really the only difference from yesterday is this is the sum. This stands for sum of n terms or n numbers. Your n still stands for the number of terms or numbers, whatever you want to add up. This is still the first term, and the a sub n is still the last term. So basically you need to know your number of terms, your first term, and your last term. You might have to use the a sub n formula from yesterday. In fact, we're probably going to have to in most of these. Each one of these examples is a little bit different. Okay, so in order to show you that there's a couple of different ways that you could see this in your homework, but not kill us with having to do a million or 2 or 3 of each kind. Okay. All right, so we're supposed to find the sum of the the finite arithmetic sequence. Let's pretend we couldn't just put that in our calculator because it's really small, right? Let's pretend that there were dots in the middle, and I didn't know what the middle part of it was. Okay, so in order to find the sum, I need to know how many terms. How many terms are in this? Count it up.
10.
Do we agree with 10, everybody? Yeah? Okay, so 10 terms. So it said that the formula says I do 10, my n divided by 2. And then I'm supposed to do the first term plus the last term. What's the first term? 1. Good. What's the last term? 19. So this one is very straightforward. This here is purely notation. It's this notation for saying the sum of the first 10 terms. All right, what's 10 over 2? 5, and 19 plus 1? 20 times 5? 100 is the sum of those first terms. Okay? All right, next one's a little bit different. Okay, let's see how much we can fill in. What is the n value this time? 50. They didn't type out all the terms for us this time, though, did they? So we got 50 over 2 for the formula. What's my first term?
-6.
-6. What's my last term? We don't know, right? ... means that keeps going. But yesterday, didn't we learn a formula that tells us the last term?
Yeah.
Couldn't I use that formula? So here's where you're going to put both formulas together. And more often than not, you're going to probably do this. Okay? So I want to find the 50th term. It said the formula from yesterday, remember, was a sub n equals a sub 1 plus n minus 1 times the difference. You guys, you need to know the formulas well enough to match the formula to its name. Okay? It'll be matching on the test for the first question on the test. Okay? So I'd make sure I understood what each formula was used for. So what's my first term of that sequence?
-6.
Good. My n value is what? 50. Could I do 50 minus 1 in my head? Yeah, what's 50 minus 1? 49. Do I know the difference? Could I calculate the difference? Isn't it just the second term minus the first term? So what's the difference? 4. All right, use your calculator. Tell me what the 50th term is. You can just do the whole calculation right there. we getting?
190.
Everybody good with 190? Okay, awesome. All right, let's do this calculation. So 50 divided by 2 is 25. Negative 6 and 190 would be 180 what? 4. All right, multiply 25 times 184 to get the sum. You got a number?
4,600.
Do we agree with Lauren? Yeah? So, even though it was kind of a pain to use two formulas, right? Your alternative, if you had no clue what you were doing and you couldn't figure out how to use the formulas on the test, was you find the difference in between them, you write out 50 terms, and you type all of that into your calculator and add them up. Okay? It could be done that way. You're wasting a lot of time, though. Okay? You wouldn't have finished as quickly as we finished with the two formulas. Okay? All right. So, there was this mathematician, and when he was a little boy, his name was, it's this guy up here in the top left-hand corner. It was Gauss. Okay? This is the story I've been told, so I'm passing it on to you. He was bugging his teacher in elementary school, so his teacher, to keep him busy, told him to add the numbers 1 to 100. He figured out this pattern of this formula and came back to her in a couple of minutes with the answer. Okay? Because he was able to use this formula that we just that we're working with today. Okay? So, first, sum of the numbers from 1 to 100. So, what's our n value? 100. So, our n is 100 divided by 2. What is my first term? 1. What's my last term? 100. What's 100 divided by 2? 50 times 101 is what?
1,050.
We agree?
Yeah.
I'm not sure he got it, but probably what happened was I bet he went and sat down and started looking at patterns. And once he added the first two, and probably once he added a bunch of them together, he probably saw the pattern of what was going on. And, I mean, that was, I don't know, when did he say he lived? 1777 to 1855, so it was a long time ago. So, they're probably better at recognizing patterns right away rather than the way we are today. So, okay. Let's look at 24. Okay? So, we're going to find the 150th partial sum. That's the same thing we've been doing all period of the arithmetic sequence. So, there's our sequence. So let's put it into our sum formula. What was the n value they wanted us to find? 150. Again, it looks, the way they set it up looks different, but it's the same stuff over and over, right?
Mm-hmm.
All right, what's your first term?
5.
5. What's the last term? We don't know. Do we know how to find it, though?
Yeah.
Yeah, we've got a formula for that, right? The a sub n formula, so I'm not going to write the whole formula out again. It's a sub 150. I need the first term. What's your first term? 5. What's your n value?
150.
It's supposed to be n minus 1, right? So what's 150 minus 1? 149. And then what do I need to multiply it by?
The difference.
The common difference. Okay, and my difference is 16 minus 5, which is 11. Okay, you guys crank out the number in your calculator. In fact, do this. Get that number, put it in here, and then find the sum. I'm going to give you a minute and a half to find both numbers. Okay, so find the number you need, the term number, and then the sum number. I'll give you about 20-30 more seconds to get both numbers. Okay, what do we get for the 150th term?
1,644.
644. All right, so 1644. All right, we had 50 times. What was this when you added it up? Did you do that? Sorry, 75. Blonde moment. All right, 1649. All right, what do we end up with when you multiplied? 675. Everybody agree? Awesome. All right, last one here. Yeah, we're going to hit a word problem once in a while. Okay. Not a bad thing. It says an auditorium has 20 rows of seats. Isn't that your n value? Okay. 20 seats in the first row. Isn't that a sub 1? 21 seats in the second row, 22 seats in the third. So it's basically saying 20 in the first row, 21 in the second row, 22 in the third row, and so on, with an n value equal to 20, which is what we've been doing all period. How many seats are in all 20 rows? So we need to find the sum of the 20 rows. Okay? So my n value is 20. What's my first term number? 20. Do I know how many are in the last row? No. Could I figure it out? Yeah, so a sub 20 equals, what's your first row? 20. My n minus 1 would end up being what? 19, right? Because my n is 20, and minus 1 is 19. And then my difference is what this time? Difference is 1. You probably don't need to write that down. The 21 minus 20. All right, so it looks like we got to add 20 and 19. What do we get? 39. All right, so let's see. I'm seeing 10, 20 plus 39 is 59, right? So 10 times 59 is 500. Probably almost, it's pretty close. I think there's about 500 seats in our theater. Be interesting to go in and count. So when you guys go have to fill out the next time you're in the theater, count how many are in the first row and the last row and see if how close we get. Okay, that's it for today. I believe I did put an assignment up in haiku. Okay, I'm going to hold off on stamping until tomorrow. All right. Oh, I know what I want to do with you guys. So flip in your notebook to page 15. Okay, your notes notebook to page 15. And let me hit stop on that.